welcome to this particular presentation on steel structures. I am very happy to introduce myself to my dear students. I am, by the way, Dr. Ramesh Babu, a professor and head civil engineering and having an experience of 25 years and various sectors, both national and international level. So, this particular session we are going to introduce the fundamentals of the steel structures and their designs, the methods, joints, connections, as well as the various members like compression members, the tension members, plate girder, roofs, all these things I will give you a general idea of this particular structure. With reference to this particular title here, one is the steel, another one is the structure here. So, what is meant by a structure? A structure is defined as an assemblage of elements. An assemblage of elements, and these elements one can see in our structure, the elements are mainly with reference to the bottommost to the top. One is the foundation part, the second one is the column, the beam and slab. So, now in case of a structure, all these elements are to be properly proportioned according to their size, and these elements, as in case of these steel structures, they are ready-made elements, not like in a concrete the monolithic structure. So, coming to this particular structural elements, we have a structure like this. We have a number of floors. One can see from this particular one, everything slab cum beam and the column. That means every element is a ready-made element. Slab is designed separately, beam is designed separately, column is designed separately, and finally they are all going to join to the finally to the foundation through means of slab base and column base. So, let me illustrate first the structural details and the code connected to this particular one. So, the steel is followed with the Indian standards IS code IS 800 2004. This is the revised code, and accordingly every rule and regulation we have to follow with respect to our design is mainly the as per the code. And the steel structures today is very popular nowadays compared with the RCC structures because of the time saving. So, the time saving here with reference to the steel structure means very fast in the construction, means everything is designed and their elements are manufactured and just assemblage or joining the elements. As far as the connecting these particular elements, the steel connections are plays a most important role, even though the design is very good as per the designs, but if the connection is not proper, these elements, the whole structure is going to collapse. Therefore, in any design one should see whether the structural members, their connections satisfies the requirements and indirectly the load carrying capacity of this particular joint. As far as the connections are considered, we can join the various elements with like beam and slab, column with the column and with the footings with the base plate. Like this we have n number of connections, and these connections are mainly, one is an axial, one is eccentric. That means in case of a connection axial, the load is passing through center of gravity, lies in the plane of the weld or riveting, whereas in an eccentric connections the load is not passing through the center of gravity. And the types of connections in steel structure, we have one is riveted joint and second one is bolted joints and third one is the welded joint. So, these particular joints, namely riveted, bolted and welded, three types of joints, accordingly they use the rivet, a riveted joint, bolt, the bolted joint, welded joint, and these connections are to be properly designed, or indirectly the failure of this particular structure mainly because of not properly designed the connections, means the failure of this particular one. As far as the methods of design, if we consider according to our latest method, the working stress and limit state method, working stress is the old one and today the limit state design is very popular. With reference to these particular methods of design, these elements, with reference to these methods of design, we have the first one is with reference to the working stress method, which was old method. Working stress. So, this working stress method, it is the stresses are working stresses, or it is nothing but this particular working stress method is based on a single assumption, that is a modular ratio. That means when we draw the graph between stress strain diagram, a stress strain diagram if you draw, so it is assumed as a linear variation, and this is the stress, this is the strain, and we calculate this particular all the parameters in the working stress method by assuming a linear variation with a single parameter known as modular ratio. And in this particular method, with respect to the factor of safety which is considered, that means the actual load multiplied with the factor of safety, you get the working loads. So, the actual loads, the working loads multiplied with the factor of safety, we use the design load. So, these working loads according to the type of structure to be considered, and as far as the factor of safety is considered, steel structure in working stress method, the old factor of safety is 1.8 in the earlier discussion, whereas with reference to RCC, the factor of safety in earlier was 3. So, now you can see this factor of safety is very high, and naturally the design load which you considered is more in this particular case compared to the present one. So, in the working stress method, only the strength is considered. The strength is the criteria which we considered, but not given anything with reference to the serviceability criteria. That means this method considered only the strength, and second one, this particular method ignores the serviceability requirements. The serviceability requirements are mainly deflection, cracks, shear, etc. So, these deflection, cracks, etc. are not considered in this particular method. So, therefore, the structure is good for the strength, whereas for serviceability this cracks gives not pleasing appearance. And the second one also here, the drawback of this particular one is 1.8, which is a very high value compared with the present, the limit state method. So, the drawback of this particular one is higher factor of safety, and naturally the strength only considered here, whereas when you come to the second method, that is a limit state method, with reference to limit state method, we considered the two things, both the strength and serviceability, and here we call the same factor of safety as, because the factor of safety is split, it is nothing but one taking care of the one material, one the strength. Therefore, we split into two, therefore we called as partial safety factor. this particular partial safety factor, that is nothing but denoted by gamma, as far as this particular one, both the strength and serviceability criteria is followed, and accordingly the value of gamma is taken in the working stress limit state method. This is 1.15. So now we can observe here it is 1.8 and this is 1.15. The steel structure compared to the RCC, steel is a costly and hence the factor of safety has to be minimized. Therefore, today this particular limit state method where the factor of safety is only 1.15 because the steel behavior is perfectly predicted at what load it is going to collapse. At exactly the stress strain curves if you plot, exactly at what load this material is going to fail. Hence the minimum factor of safety is considered. Naturally the design load which you considered here, when you multiply with the working load with the factor of safety, the steel structure it takes very less value 1.15, whereas in case of RCC it is equal to 1.5. So now we can see the difference in the old structures which we designed and the present structures with reference to 1.15. So always the advantage of this particular limit state method is, one, we know the collapse load, at what load it is going to collapse, and second one at service load. That means a structure is designed for the maximum or ultimate or collapse load and the structure is used for the working loads. This is the beauty of this particular limit state method, and one can see from this factor of safeties of 1.8 and 1.15. So as far as the load is considered, in this one the design load is more, naturally the bending moment is high. With reference to bending moment and the size of the member here, with reference to the bending moment, M is equal to Fz. Bending moment is equal to stress into section modulus. This is section modulus. And this bending moment is a function of the load. The bending moment is a function of load. Since the load is less in the limit state method and compared to the working stress method, so left hand side term will be less the working load, and compared to the previous one, naturally this Z is a function of B and D, that is a cross section dimensions. Normally this value is less, automatically B and D, the size of the section is very small compared to the previous methods of limits working stress. So in a limit state method, one is safety is considered, strength is considered, and moreover the bending moment, the load is less here because of the factor of safety which is 1.15 when compared with the previous one 1.8. So naturally the size of the section is less. That means it is indirectly making a sentence, the duty of an engineer is to economize the constructions. So here the size is reduced, thereby we are maintaining economy in our construction. So these are the methods of design of these particular structures, that is, one is the limit state method and another one is the working stress method. With coming to the topics of these particular connections as well as the designs, the main difference with reference to the design of steel and RCC structure here, in case of steel we calculate the value of the B and D and we are going to check the structure is going to be safe against the shear or deflection, some checks are to be done. Whereas the design here means it is M is equal to Fz, so Z is equal to M by F or Z is equal to I by Y. So this equation from theory of simple bending, we have an equation E by R is equal to M by I, which is equal to F by Y. So E is the Young's modulus, R is the radius of the curve, M is the bending moment or moment of resistance M, I is the moment of inertia, F is the bending stress, Y is the distance of CG. So this particular equation will be very clearly used to analyze the section by, in this particular section we are going to solve the Z and according to the jet from the steel table we are going to select the section. So as far as the question, if it is considered, the syllabus, the question, exactly the important topic. With reference to the important topic, with reference to the JE and RRB, both SSC and RRB, the very clear cut the syllabus here is the first one, design of connections. In this design of connections, all the riveted, welded, bolted are going to be analyzed with reference to the code. That is the first one, mainly everything as per IS code with reference to the spacing of the rivets, that is we called as a pitch, and the gauge between the rivet lines. Pitch and gauge are very important, and similarly the load carrying capacity. That means the failure of the rivet can take place either in the shear or bearing or tearing. So these are the important points from the connection point of view. With reference to the welded connection, the length of the weld, how to be calculated. So this is a syllabus, and remaining is nothing but the eccentric and the beams as well as the tension members and compression members, roof trusses, and as well as the plate girder. These are the topics of the syllabus for your RRB and JE and as well as SSC. So coming to the next question, with reference to the theory or problem, as you mentioned here, the maximum theory or problem, it's a very good question. As in any competitive examination, the planning should be very well, means how we have to prepare. So coming to this particular question, Mr. Naveen, it is very clearly mentioned, that is the first one, theory. The theory means doesn't mean like a simple statements. The theory question clearly refers here the mainly the law, that is means rule. The rule is with reference to, as I mentioned, one riveted connection, what is the spacing between the rivets? What is the, that is we called as a pitch. So this pitch with reference to tension member, with reference to compression member. So most of the questions with reference to this particular part here is clearly with reference to the code book rules and simple calculations, because the calculations takes tedious calculations, because the time it takes more. Second one, with reference to Amit, maximum jet is with reference to the jet value here. So the jet means here with reference to section modulus, which is nothing but I by Y. So in this equation, this I by Y, M is equal to, if you use this particular equation here, M by I is equal to F by Y, or M is equal to F into I by Y. So this I by Y is nothing but Z. So this value of Z which you choose from your section when you are designing, is it a maximum or minimum? So maximum or minimum is not a question here. The section should be economical. Economical means the nearest value to be chosen, accordingly the moment of resistance it will bear. If you choose lower value, naturally the bending will be more, resistance cannot be there, the section is going to fail. Always when we are choosing, whatever the value of the Z it is required here, Z required, this Z required will be always the Z provided is always more than the Z required. So that is what, how you have to provide in your design, the required section modulus which is Z, and the provided Z is always more than the required, and no more than means it is not more or high, to the nearest value we have to choose little more. So coming to the next question, rivet strength. As far as the rivet strength here, strength of the rivet is nothing but, the rivet strength is nothing but the load carrying capacity indirectly. So normally the rivets strength can be calculated based on strength of rivet in the shear, PS, strength of rivet in tearing, strength of rivet in bearing. So naturally the three cases which we are going to calculate strength of the rivet and strength of the rivet in shear, that is a load carrying capacity in shear, bearing and tension, and accordingly whichever is the least value among this one we calculated as rivet value. So this rivet value I considered among all the three failures here. These three failures I choose the least value because my number of rivets are based on rivet value, load divided by rivet value. So you can see this equation, load divided by rivet value. So with reference to load divided by rivet value, so if I choose the higher value, I get the number of rivets less. Maybe in one case it may satisfy, whereas in other two cases it may not be satisfied. So if we choose the lower value, it satisfies all the requirements of the shear, bearing and tearing. Therefore, we choose the rivet value as the least of all PS, PT and PT bearing, shear and tearing. So coming to the next one, regular Mr. Muhammad Ravi, which shape of section have the maximum Z value? So the maximum Z value you can see from this particular one, I by Y. So the circular section you can take it one next to that one I section. So I section and circular section, if you take it the value, so the concept of this particular Z value, that is when you are choosing here based on the moment of inertia. So the moment of inertia for the circle, if you take it, Ixx is equal to Iyy, whereas if you take for I section, Ixx may not be equal to Iyy. Therefore the circular section is the best, but in steel structure the next section is I section. Coming to the, this is what the maximum Z values. Karthik, why do we course Z provided shall be less than the Z required? So Z provided less than Z required. So if you meaning itself, as I mentioned, the Z required value, Z required means from this particular equation M is equal to Fz. So the left hand side of this equation is the resistance. Moment of resistance. Moment of resistance means against the bending. So moment of resistance is, if you choose the value of Z is less, indicating indirectly our moment of resistance is less. Moment of resistance less, it shows that the bending is more or the section is going to fail. That's the reason always Z provided must be more than the required value. Hope Mr. Karthik satisfied your question. Coming to Mr. Satish, among this least one is provided. So why this is the least one? As I mentioned here, shear, tearing, bearing, among all these things we choose the least value to be provided. The reason is, if I choose the least value here, my number of rivets are more. That means number of rivets are more, naturally each rivet has its own strength, more rivets it carries the more load, or in other words all the three failures will not occur. If you provide only higher value, one case the rivet will be safe, either the shear, load or tearing, whereas in other cases it will not be able to provide. That means the shearing, bearing and tearing, in general most of the times the shear failure is the lowest value in general case, and which is normally going to be considered. That's the reason we have to take the least value as the rivet value, that is number of rivets will be more. If we take it opposite, higher value, number of rivets will be less, the connection is going to fail. So coming to the Sunkara, please explain three failures, tear, bearing and failures. Let us see these particular failures: shear failure, bearing failure and tension failure. As far as the shear is considered, with reference to the shear, shear is nothing but unbalanced vertical force. A shear force is nothing but unbalanced vertical force. So coming to the shear failure, suppose if we take a connection, if I join these two plates, the plate 1, plate 2, if I provide a rivet here, when unbalanced force, that means due to this unbalanced vertical force, the shear is introduced into the beam or any section because of the variation of the bending moment. So bending moment is varying from one point to the other point. Naturally, the shear also will be varying. That means the relation between shear and bending moment, so F is the shear force and M is the bending moment, and F is equal to dm by dx. So this value of M is not constant. M is variable in any structure, therefore shear force also varies, and accordingly due to this shear, the unbalanced force which causes the failure of this particular rivet. So once this is the failure. So one we can observe from here how the rivet gets failed. Means here the rivet is, failure plane is only one here. The failure plane is rivet broken into two, which is known as the single shear, The rivets are in single shear if the rivet fails like this. Whereas if we take the rivet's failure with reference to the double riveted double cover, suppose if you are having like this we have, and the failure of the rivets here, again the double riveted, if you provide two rivets and with the double covers, so the failure of the rivet like this. So whenever we have double riveted double cover, so rivets are in double shear, double cover. So for example you have the one I section, we have, this is one I section, I am going to provide two cover plates here and I connect by means of this one. So you can observe these failures at the 2 points here and here. When a rivet is broken, you have the two failure surfaces, which is known as the double shear. So here one shear failure plane, here another one. Because of rivets are in double shear, we can say that rivet failure taking place like this, it broken into 3 parts, it broken into 1 part. This is called shear failure. Coming to your question with reference to the value of tearing and bearing. So with reference to tearing and bearing, means the failure of the section, either the plate fail or rivet fails. So in case of the tearing, if the plate is made with the strong material, the rivet is going to fail. So the rivet fail means the plate is made with the strong material, and the plate fails means it is made with the very weak material, rivets are strong, so only the tearing will take place. That is why we provide sufficient edge distance to be provided to the sides, otherwise here the tearing effect will take place, means plate is broken and crack will be developed. As far as the bearing, it is nothing but the crushing. So the bearing stress into area of the rivet, which is to be considered in calculating. In all these cases, the simple formula, load will be equal to stress into area. So this area, shear cross sectional area, and thickness B into T is the tearing, and the tension again tensile stress into area. So in all these formulas, only the thing is stress into area is nothing but the load carrying capacity. Coming to the Yogaraj Sahu objective book. So thank you very much. So this is the end of this session. We will meet in the next session. Till then, so keep preparing with the Gradeup to score better and take it challenge and make it success. Okay, sir.